Continuing where we left off, we have two more examples of working with complex numbers. All right, for number 7, the problem suggests that we might want to distribute the 4i into the parentheses. After we're done distributing, we look to see if we have any more simplifying, which we do. I squared, as you remember, is equivalent to -1. Keeping the 32i, there's nothing we can do there to simplify that term. Where I squared is, I'm going to replace I squared with -1. So we end up multiplying. 32 minus 20. Common practice to put it in standard form would have us put the real part up front. So just rearrange. -20 plus 32i. Looking at example 8, we have a lot of algebraic work to do here. We're going to have to FOIL two binomials and then subtract the second expression from the first one. So observing this first binomial, okay, over here I'll do some side work. I'm going to end up multiplying 4 plus 5i times quantity 4 plus 5i. And some of you could probably do this mentally, so you don't need to show this work over here. When we FOIL, remember first terms, outside terms, inside terms, and last terms multiplied together. So first is 16. The product of the outside terms would be 20i. Inside terms also 20i. Last terms multiplied would produce 25i squared. As we move back over here to the problem, we can do some cleanup here as we transfer back underneath our work. So for this binomial squared, I'll replace it with this cleaned up version that I have here. So 16 is good. Okay, these will collect to 40i. As I move from over here, my scratch work, my side work, back into the problem, remember I squared is equal to -1. We end up multiplying by the 25, so our sign is going to change and we're going to have minus 25. I am going to be able to collect 16 and minus 25, but I'll do that in the next step. Okay, back into the problem, I have subtraction. Okay, you can use parentheses or brackets. Ooh. Sometimes I just like the visual of the bracket. Okay, we're going to come over to the side. We're going to do some scratch work. We'll FOIL 4 minus 5i times another 4 minus 5i. So first term 16, outside terms minus 20i, likewise inside terms. Two last terms multiplied is plus 25i squared. And we will, as we transfer back over here, do some cleanup too. So I'll keep the 16. I'll collect the I terms, minus 40i. And again, I squared is -1 to be multiplied by positive 25, so that turns to minus 25. All right, next step, we might want to distribute the minus. You have a couple of choices. You can collect the 16 and minus 25. If you want, you can collect this 16 and minus 25, and then you can distribute the negative. Or if you want to distribute the negative through all these terms and then clean up, and that's the route I'm going to take. As long as we do the steps correctly, mathematically correct, we should end up with the same answer. So distributing the negative, minus 16, etc., plus 40i, plus 25. All right, maybe we can cancel some things and we won't have to do the computations. Well, 16 and subtract 16, cancel. Minus 25 and plus 25 will cancel, so we're left to collect two 40i's, which make us have 80i. All right, continuing our work with complex numbers, the next topic is looking at complex conjugates. If you're given a number in standard form, a complex number in standard form, and it takes on this form, if you were asked to, given this form, write down its complex conjugate, complex conjugate just means that you're just changing the operation between the real part and the imaginary part. So if it starts out addition, you're going to change addition to subtraction. If it was a minus bi, the complex conjugate would be a plus bi. There's no sign change on the leading terms. All you're doing is changing from subtraction to addition or addition to subtraction. Why we care about complex conjugates is because they have some interesting multiplicative properties. All right, so if you're given an example on your homework and you're asked to find the complex conjugate of the number 1 plus I, we're going to say that the complex conjugate is 1 minus I. Part of the instructions are going to ask you to multiply by the complex conjugate. So if I want to multiply by the complex conjugate, that would indicate that I might want to put 1 plus I in parentheses and put its complex conjugate 1 minus I in another set of parentheses. So multiply by the complex conjugate of the given problem. So we started out with 1 plus I, we produce its complex conjugate 1 minus I, and then we continue by multiplying by foiling. Just foiling. First, outside, inside, last. So first, outside, inside, and last. And as mentioned earlier, they have some interesting multiplicative characteristics. So first terms produce 1. Outside terms would be minus I. Inside terms multiplied would produce plus I. Okay, and stop right here for just a second. Notice that anytime you multiply by a complex conjugate or a conjugate, in the word FOIL, the O product, outside, and the inside product will be opposite terms, so they'll cancel. I don't even need to consider them, but I just wanted to illustrate with the recording here first, okay, that they would cancel. All right, well, we're at F, O, and I. Now I need to do the L part. The last two terms multiplied would be minus I squared. Of course, we want to continue and clean up. These will cancel, and we're left with 1 minus I squared. All right, we can continue. I squared is equivalent to negative 1. So we have 1 minus negative 1, so we have 1 plus 1. So our final answer is 2. When you multiply a complex conjugate, when you multiply a complex number by its complex conjugate, what happens is you end up eliminating all the I terms. All right, let's look at another example of what we might do with complex conjugates. So there's our problem. The directions are multiply by the complex conjugate. Okay, so if I'm going to multiply by the complex conjugate, I'll put this in parentheses, and in the second parentheses I will produce its complex conjugate. So again, remember, we keep the sign of negative 4. The only thing we're doing is changing subtraction to addition or addition to subtraction. Okay, if we're going to multiply a number by its conjugate, so we're going to have to FOIL. But instead of foiling, all we're going to have to do, because these are sum and difference of like terms, these two are alike, and these last two terms are alike, and we have a sum and difference. Okay, you can FOIL, okay, but your O and your I terms are going to end up canceling. So to save us some work, if we see the pattern, I'm going to get 16, and then I'm going to multiply the two last terms together. Minus 9I squared. Okay, and the I squared here in a minute is going to change to -1. So we have 16 minus 9. I squared is -1 equals, this becomes 16 plus 9, so the final answer would be 25. If you want to replace I squared, okay, with a -1 and show it this way, that's fine. If you want to end the work right here, just say, hey, I squared is equal to -1, and within here you see that that changes to +9, and go to the final answer. Your choice, whatever you're most comfortable with. All right, continue our work with complex numbers. The next objective is to write in standard form. So if you see these directions, write in standard form. Okay, we know that we're going to take our final answer and write it of the form a plus bi. All right, let's look at an example of what they want me to do to write in standard form. I'm actually going to write a fraction here for our problem. In this problem, notice that you have a complex number in the numerator and a complex number in the denominator. One of the things when we work with complex numbers is that we try and eliminate any i's that might fall in the denominator of a fraction. So right now this is kind of an illegal math thing for us. We don't want to have I in the denominator. So how do we get rid of I down here? Well, we're going to use our previous work with complex conjugates to help us. All right, so here's our problem. Directions are write in this form, basically meaning get rid of the I in the denominator. Our procedure or steps in doing so would be to multiply by the complex conjugate of the denominator. So let's multiply by another fraction that includes the conjugate of the denominator. So 4 minus 2i will change to 4 plus 2i. Okay, and since we want to multiply by a form of 1, an interesting, clever form of 1, we're going to go ahead and take that complex conjugate and put it in the numerator too. This just equals 1, and then we're allowed to do that. It won't change the value of this answer. All right, so focus your attention on the denominator, create its complex conjugate, and then reproduce that also in the numerator. So we have a lot of algebraic work here to do. All right, basically we're going to end up multiplying two binomials in the numerator and then these two binomials in the denominator. Let's start our work with the denominator first in multiplying. We see that we have the sum plus and difference minus of the two like terms up front and the two like terms back here. So we know we don't have to actually FOIL. We can eliminate the O and the I. So let's multiply the two 4's together, first terms, and the two last terms together. I know I squared will change to -1. This will change to +4. My denominator is going to be 20. I'll do that in the next step where I clean it up. But think about 20 being in the denominator. That's good. I got rid of the I. That's the whole purpose of multiplying by the complex conjugate, is you get to a real number like we saw in the previous examples. All right, well, unfortunately our work's not done. We have a lot more to do in the numerator. Well, no shortcut here. I have to do the entire F, O, I, and L. So that's what I'm going to do next, is FOIL these two binomials together. Let's do some cleanup on top and bottom. Okay, in the numerator I see I squared is going to change to -1. So that'll be a -6. So I'll end up with an 8 collecting with a -6. So I'll end up with 2. And when I collect these two, I'll have 16i. Again, down here this changes to -1 times a -4. That becomes 16 plus 4, or 20. Okay, if we're going to follow the directions and write it in standard form, it looks like they want it separated into two parts. So what I could do right now is put the 2 over the 20, and I can also put the 16i over the 20. And we should continue and simplify. So 2 over 20 is 1/10 plus, let's see, 4 goes into 16 4 times and 4 goes into 25 times. So we'll have 4i on top and the 5 down here. Okay, that's a lot of work, but what we did is we took a fraction that had an I in the denominator, and to write it in standard form, we multiplied by the conjugate of the denominator, reproducing that conjugate in the numerator to have a form of 1 here, and then we just did all the algebra here. Okay, let's look at another example of writing in standard form. For our second example, it looks like it might be a little easier because we don't have a binomial in the numerator. All right, to write in standard form, get the I out of the denominator, the conjugate of which is 4 plus 5i, put it in the numerator here too. Okay, well, I'll start with the denominator. I know that's going to be 16 minus 25i squared. I don't have to FOIL, just F and L. This will change to plus 25. We'll take care of that in the next step. All right, going back to the two numerators, all I'm going to have to do is distribute the 2, multiply it to both of these, so I'm going to end up with 8 plus 10i. I'll just carry that over. My cleanup is just in the denominator, so that's negative 1 times negative 25 is plus 25. So 16 plus 25 is 41. And we could split this apart. Oh, excuse me, 41. And then plus 10i over 41. And neither 41. I don't know why I keep wanting to write 4i. So 41. So a couple of examples of writing in standard form when you're dealing with fractions and how you have to multiply by the conjugate to get I out of the denominator. Okay, one last objective. Hang in there. All right, the directions for this next set of problems is to simplify and put our answer in standard form. So let's take a look at two examples of which they're saying that we need to simplify. I know how to simplify I squared. It's equivalent to negative 1. It's the I cubed. So for our work with higher exponents on I, we need to come over here and look at how I with various exponents are defined. Okay, so I is equal to the square root of negative 1. I squared is equal to 2 of these i's multiplied together, negative 1, or square root of negative 1 times square root of negative 1, which same radicals multiplied produce negative 1. We know I squared is equal to negative 1, but what's I cubed? Well, you can think of I cubed in your work with properties of exponents as being I squared times I to the first. Well, we have I squared and I to the first in these previous two lines. So I squared is negative 1. So I'll replace I squared with negative 1. And I to the first is just I. So I cubed is negative I. All right, what's I to the fourth? I to the fourth can be thought of as I cubed times I to the first. You could even think of I to the fourth as I squared times another I squared. Because remember, same base, add the exponents. I chose I squared times I squared because I know I squared is equivalent to negative 1. So I'm basically just multiplying negative 1 times negative 1, and I get positive 1. We could go on all day doing this. But there are some patterns that start to develop, and you should be aware of them. I to the fifth, you could do I cubed times I squared, because 3 plus 2 is 5. You can do I to the fourth times I to the first, because that would be I to the fifth. Okay, so I to the fifth, I'm just going to use I to the fourth times I, because that would give you I to the fifth. Well, I to the fourth is positive 1, and I is just I. Multiplying, I just get I. Look at I to the sixth. Well, it's I cubed times I cubed, because 3 plus 3 is 6, or you could do I to the fourth times I squared, because 4 and 2 make 6. You could do 5 plus 1. Well, I to the fourth is 1. I squared, it's back up here, is negative 1. So that answer is negative 1. Okay, look at I to the seventh. I to the fourth times I cubed. Well, I to the fourth is positive 1. I cubed, way back up here, is negative I. Ooh, get back here. So that answer is negative I. Hopefully you see the pattern that's developing. I to the eighth. Without doing all this work, let's see if we can figure out what I to the eighth is. Well, if we have I, negative 1, negative I, positive 1, then we go to I, negative 1, negative I. Following the pattern, I to the eighth, which is a multiple of 4, is just going to be 1. The pattern starts to repeat. I to the ninth would just be I to the 10th would be negative 1. So every 4, the pattern repeats with these 4 answers. So multiples of 4, okay, repeat the pattern. All right, so let's come back into the problem over here. I know it's long, but hang on. All right, so if it says simplify, we don't want any exponents on I other than 1. So I'm going to keep the negative 6. I cubed, I come back over here and say, oh, that's negative I. That's a good imaginary number, first exponent. I squared changes to negative 1. So I would clean this up. 6I minus 1. Standard form would have us put the real part up front, so just rearrange negative 1 plus 6I. So in order for us to tackle these problems, we need to know higher exponents on I, and we've got a pattern that's going to help us. So one more example. All right, for our final example, I don't see any i's in here, but eventually we're going to have to know this information to help us simplify this. This radical negative 75 cubed, I'm going to go ahead and expand it and write out 3 of them. Okay, I know I need to pull the I out first. So I'm going to have I squared root of 75, but I'm going to kind of get myself ready. I know 75 is 25 times 3. And so I need to do this 3 times. All right, so I've tackled pulling out the i's. Now we want to multiply all 3 of these together. Well, I guess before I multiply them all together, I might actually pull out the 25 as 5. So each of them would be 5i radical 3. So I'll write that 3 times. And when we multiply these radicals together, then I'm going to multiply 5i times 5i times 5i. So 5 times 5, 25 times 5. That's 125. And then I times I times I cubed. And then I've got radical 3 times, well, these two will produce a 3. So I'm just going to go ahead and put all 3 of the 3's underneath one radical and then take an extra step to simplify. Okay, I know I cubed is over here is negative I, so if I replace I cubed with negative I would put the negative up front and make it negative 125I. I'm going to put that in its own parentheses. Now let's tackle this right here. Under a square root, if I have two of the same, I can pull out a 3. So I have 3 times radical 3, 1 3 left inside. A little more cleanup. I'd multiply the 3 times the negative 125, so that'd be negative 375. I'd keep the I and then the radical 3. Alright, that was a lot of cleanup there, a lot of steps for that. And again, there's different orders in which you could go, but if we did everything correct mathematically, we should all end up with this answer right here. Thanks for your patience.